let's take a look at step one. Okay, let's see, what's my claim? They wishes to see, again, that's sort of similar to a claim. If the average weights of males are different than average weight of females. So my claim here is going to be that the mean weight, mu1, mu of males, is different. What's the word for different? For symbol for different? Not equal to. Everybody on board?
Yeah.
That one gets a little tricky for folks. Right? Different means that you're not the same. If you're not the same, you're not equal. Not equal. So that means in step one, we're looking at mu1 is equal to mu2. That is not my claim. My claim is that they're different. Oh, sorry, that's h1, h naught. H naught is this, which means that h1 is my claim, that they're different. So I'm going to use the word support later on. And then step 2 is pretty straightforward, right? That's just alpha. 5. Okay, so then step 3, I strongly, highly recommend you make a little list over here of what is N1, X bar 1, S1. Okay, just make a little, and do the same thing for the second one. Females, sample of, so that's sample of, again, sample of is always your N, and then your X bar and your S will always have units, in this case ounces, right? They'll have labels. So make sure that you find those pieces. Plug them in. Just to reiterate, H naught is only my claim when my claim is that there's no difference. When my claim is that they're the same. My claim is that there's no difference, that they're the same, that's when my claim is H naught. Right? When my claim is that it equals something. My claim is that they differ, they're different, then my claim is that they're not equal. My claim is that they're not the same. So in this case, my claim would be H1, that they're different.
Oh, wait.
They're not equal.
Sorry, did wrong.
All right, so step 3. So my N1, let's see, reading through here. Random sample of 10 males. Mean of 123, standard deviation of 8 ounces. So my N1 is 10, mean is 123 ounces, and standard deviation is 8 ounces. Remember, the mean standard deviation, those will have numbers associated with them, like labels. And then the females,
You put all the same numbers.
we had 8 of them. 116 ounces is their mean, and 5 ounces is their standard deviation. So I'm going to plug all these in. I'm going to do, we're going to do 2 sample p-tests of, is it X bar then S then N, is that right?
Yeah.
123, then 8, then 10. 116, then 5, then 8. Not equal to, pooled should be no. And you all got for your t-score?
2.27.
Point what?
2.27.
2.27? And for your p-value?
0.03.
Point what?
0.38.
038?
383.
383?
Yeah.
Okay. Alright, is that back with everyone else got?
Yep.
Great. So then in step 4, my p-value 0.0383, my alpha is 0.0500, 500 is definitely bigger than 383, so I'm going to reject H naught. Which means that I reject H naught means I have enough evidence to H1's my claim, so support my claim. The mean weight of male and female newborns differs. Okay. Good. All right, everybody feeling good with this one? We're just going to go ahead and match up with their corresponding confidence intervals. Again, the confidence interval is going to be our statistic, x bar 1 minus x bar 2, plus or minus our error. But again, we're going to skip all that and just go straight to the 2 sample t interval, making our life easier. So for example, our color creativity, remember that one again was an alpha was 0.05, and it said that the blue was bigger than the red. So since that's one-tailed, we're saying that this is 5%. If we're doing a confidence interval, we're looking at that middle part here. This middle section here would be, there'd be a matching 5% over here, and the inside part here would be 90%. So that's why we're doing a 90% confidence interval, because we're switching from one-tailed to two-tailed. So I'm going to look at the 2 sample t interval. I'm going to put in my x bar 1, my s1, my n1, x bar 2, s2, and n2, and then the 90% confidence interval, cooled no. And we will magically get negative 0.905 to negative 0.2546. So in other words, the difference between them is negative. What that means is the first mean, since it's all negative, I will look up. See how it's all negative, my confidence interval? That means the first mean is entirely less than the second mean, because all the options are negative. So in a sense, because it goes negative, negative, that means the first one must be less than, must be negative, smaller than the second one. And that's what we found. Right? We did find evidence that the blue does increase creativity. So that totally matches up with that. Right? So it does not include 0. There is a difference. And in fact, the difference is negative. The first one is less than the second one. So the red group was less than the blue group. Am I going too fast?
No.
Right. So we're going to go ahead and have you folks do lab problem number 5. And we're going to find they were saying that they're different, so it's actually going to be a 95% confidence interval. Right, so go ahead and do the same problem you just did, and we're going to do the interval for it instead. Okay, let's take a look, see what we've got. So you folks did, this should be your result, because you did 2 sample t interval of all of your pieces. What were your pieces? Your pieces were 123, 8, 10. Was it 116? 5, 8. Thank you. 0.90. No. Good. And you'll see, what was my interval? It was 0.43 to 13.569.
0.95.
Was it?
You said 0.90, it's 95.
Oh, sorry. It is 0.95. My bad. Thank you. What you'll see is the interval goes from 0.4 to 13.6 roughly. It's all positive. So it means the first group, the boys, is all bigger than the girls. So it means that the mean weight of the boys is larger than the mean weight of the girls. How much larger? Well, anywhere from 0.4 ounces to 13.6 ounces. So this confidence intervals, the hypothesis test just says, yes, they're different. This one says, how much different are they? Well, it says the first group is bigger by this much, right? Between 0.4 ounces and 13.6 ounces. So that kind of gives you sort of an idea of how much we're looking at. Good? All right, great. The last thing we're going to cover is going to be dependent samples. So these are different than independent. Independent is you take a group, take another group, the groups have nothing to do with each other. This is different. Dependent, you take a group randomly, and then everybody in the second group is matched up with someone for the first group. So those are not random at all. The second group depends entirely upon who you picked in the first group. For example, presidents and their opponents. I pick Lincoln, Kennedy, Bush, one of the Bushes, I don't care which. Did I do JFK already? I did that one. Washington, there's another president. Adams, there's another president. Okay, I can remember presidents. Then each of these ones is dependent upon who was picked, who the president that was picked. So if I pick Lincoln, I have to pick Lincoln's opponent. I can't match him up with Kennedy's opponent. They're matched pairs. So they're all matched up. How do you figure them out? Here's the thing. The biggest problem some people will make is doing a two-sample independent test on this instead of dependent test. You get different results. You will lose 7 points on the exam. That's like almost a whole, that's like 2/3 of a grade, right? So pay attention to it. How do you know? They're matched up. Do you see that? They're matched up together. They're not just a bunch of numbers and a bunch of numbers. They're all matched up with their partner. When you see that, right away, you should be saying, oh, that's a two-sample dependent. I need to subtract them and work on their differences. So what happens is you do this. You subtract them. 189 minus 170, 19. This is negative 12, 8, 0, and 1. After that, you no longer care about it. It's no longer a two-sample test. Now, it's a one-sample test on their differences. Everybody on board with that? So what we do when they're dependent is we subtract them and then turn it into a one-sample t-test based just upon their differences. Here's a little bit of notation, which you don't have in your handout. I didn't think it was that important, but I do want to talk about them. D are those little differences, right? All those ones I subtracted. These are all the little d's, right? The individual differences. It's kind of like x, only because they're differences, we call them d's instead of x's. And then we have the mean of the d's. We have and I think you can actually look at this as maybe as x bar sub d. That might be the same thing. Might be easier to think of that one. The sample mean of the d's, standard deviation of the d's, the number of d's I have, number of pairs I have. There are some requirements. The sample data are dependent. The samples are, so the first group was conducted by a simple random sample. The second sample is dependent upon the first sample. And then, as always, they either need to be normally distributed or have an n larger than 30. This is the how do you find the t-score for it? Though, again, we're just going to use t-test with our mu naught equal to 0. So the difference should always be, we're saying the difference is 0. I'm going to talk about that in a second. And then there's the confidence intervals for them, which I don't know that I'm going to give you a confidence interval for them, so I wouldn't worry about that as much. What I want to do is go through an example so that this makes more sense to you. So let's take a look at the example. The claim is that for heights of presidents and their opponents, differences have a mean greater than 0. In other words, presidents are taller than their opponents. That means that the mean of the presidents, mu1, is greater than mu2. Everybody good with that? But whenever we're talking about dependence, we're going to get down to little d's, so we're going to only talk about mu d. If I subtract minus mu2 from both sides, what do I get? mu1 minus mu2 is greater than 0. Is everyone following me? Yes, no? So I just subtracted mu2 from both sides. mu1 minus mu2, we call that mu d. So this is my claim. So whenever we're talking about dependence, it's no longer mu1 and mu2. I want you to think about it in terms of just mu d. For two reasons. One, it helps keep it separate from the two sample mean, independent means. And two, it makes you realize that we're just talking about the mu of the differences. We no longer care about these two groups. We only care about these guys right there. Is everyone sort of following me? So it's all about the differences. Once you subtract them, then those two groups cease to exist in your mind. You only care about the differences. You're going to run a one sample t-test on the differences. So my first step is going to be h naught is that mu d is equal to 0. The differences are, there is no difference. They're the same. Okay. If mu1 is equal to mu2, the differences are 0. So this is a one sample t-test when your mu naught is 0. Please do not confuse now and go back to chapter 8 where we have, I think that the maximal volume of oxygen for joggers is greater than 63. Don't make that 0. That's still 63. Don't mess with your chapter 8 single sample ones. It's only when you have mu d is equal to 0. Does everybody follow what I'm saying? So the differences are 0. When you have two samples, that's when your claim is 0. Only when you have two samples. Okay. H1 is my claim. Mu d is greater than 0. That's my claim. I'm going to use the word support. Step 2, my alpha. Alpha is it 0.05?
Yes.
Great. Step 3, I'm going to do a t-test on these numbers. My mu naught is 0. I'm going to do data. So I'm going to use list 1. I'm going to put these guys into list 1. My differences. I'm only going to use them once. And my claim was greater than. I'll show you what I mean. So now on the calculator, I have put them, the differences, into list 1. And then I'm going to do stat, test, t-test, data. My mu naught is 0. My list is list 1, frequency 1, I only want one of them. And my claim was greater than. Calculate. Bam. There I have my T is 0.628 and my p-value is 0.2819. That's good. All right, moving right along. Step 4, my p-value 0.2819. Oh, that's way bigger than alpha. I don't even need to write alpha. That's so much bigger. So I'm going to not reject H naught, which means that in step 5, there is not enough evidence to support, from step 1, support claim that, what was my claim? That presidents are taller than opponents. That is it. If you want to see it prettier, I do have it typed out. Here's step 1.
Oh, we can't see.
Oh, are you kidding me? This whole time I've been writing stuff and you haven't been able to see it. This is awful. Okay. So, yeah, hit me up with that sooner because I totally screwed that up. So my t-value is 0.628. P-value is 0.2819. So since my p-value is way larger than alpha, I do not reject H naught, which means I do not have enough evidence to support, from step 1, our claim that presidents are taller than their opponents. And again, if you want it prettier, I do have it in these steps here. And that is it for today. We're actually getting out of here a minute early. Yay. Have a good weekend.